Hello. Good almost afternoon. It'll be afternoon in 3, 2, 1. Good afternoon. Does any of you like to cook? Raise your hand if you like to cook, if you ever cooked in your life, ever. An omelette, prepared cornflakes, anything. So you prepare food and you get it right the first time or the second time, and then you go for the third time and it comes out differently, right? You don't always put the same amount of salt or whatever you used, your magic recipe. Sometimes it could get really bad, right? So chefs, for instance, have their own secret recipes, and they give exact instructions to the people who actually make the food. And they want the dishes to come out the same every time, okay? The same taste they want to pass on to the diners. But it doesn't always work that way, just like when you do it at home. But what if you could? What if there was a magic machine that you get a chef to put his or her magic recipe, and this machine will always give you the same dish, the same super tasty dish. Would you like such a machine? Anyone? So actually, there is such a machine. A friend of mine invented it. Let's see. It's called, the company is called Kitchen Robotics. It's actually called Bistro. I don't put the sound, don't expect any sound. But what happens is that a chef comes to their machine, gives the instructions to the machine, tastes, changes a little bit, then puts the new instructions, and so on until the chef is completely satisfied from the result. And from then on, this machine doesn't look so sexy, but it's good. Gives you the same dish from the chef on every order. Okay? It's pretty amazing. I really like it. And that's the power of automation. Okay? You can get the same results, same reliable results over and over again. Okay. And that's what we're going to talk about today, not cooking, but automation in our software. Okay, we all go to production, I think, and we want our software to be more reliable, higher quality, and work less, right? I'll show you some code how to do that, but automation and quality is usually connected to continuous integration, continuous deployment. Okay, we always integrate the code of our team, and then we want to deploy it. And we want the same quality to repeat itself on every iteration. But it doesn't end here. Okay, automation can come in every aspect of our lives. It can be in team management, can be even Slack messages, your calendar, and food. You just saw that. So we'll go even beyond CI/CD today, and I already told you what automation is, but GitHub Actions, how many of you are familiar with GitHub Actions? Raise your hands. Good, so pretty good amount. So GitHub Actions is a service by GitHub that allows you to run scripts on remote machines, on everything actually, but usually the main usage is to be used on your code base. And we'll soon see how it works. So as I said, the main usage is to work on your code base, and we want our code to be with the same quality on every deployment. How does it work? Okay, it's the main idea of CI/CD. So we'll start with the integration part. Okay, it usually starts with a pull request or a push to a pull request, and then we run several standard gateways. Okay, we build, we make sure the build is working, we lint our code, we test our code, visual regression, you can do integration tests, whatever. Any standard your team wants to uphold. After everything passes, okay, one of the standards can be a code review. We merge to the main branch, or the develop branch, or however your team is working. And then we know that our main branch or develop branch is of a certain quality, because the same test, the same process is filtering the bad code from getting merged. So after we merge to our main, we want to start to deploy the code. Okay, we have our code base is updated. Now we want to show it to the world, so we can add more quality tests to make sure that after the merge nothing broke. It happens sometimes. And then we probably raise a version or whatever, and then we deploy. Okay, deploy can be deploy a static website, can be publish a package to NPM, can be publish a whole Kubernetes infrastructure. The idea is that everything happens automatically, and we don't have to actually sit and do manual QA for our whole system, because we're never gonna catch all the possible bugs we can put in the system, or test thoroughly all the use cases. But if we put automated testing and automated processes that check everything, we take the load off our developers or the code reviewer, and we can focus on the business logic. How does it look on GitHub? So this is how it looks on GitHub. Okay, this is our code from production. Can you see it? Yeah. So you see, there's a flow here, and that's a flow of our integration. Okay, it starts with some processes. We check even change logs, linting, everything I talked about till today. We even deploy a demo, so our reviewer, the code reviewer, can actually see the results of this merge without installing locally. And it would probably vary between teams and needs, but that's how a flow looks like on GitHub or GitHub Actions. And how does deploy looks like? Kind of the same. Okay, this is deploy of one of our libraries, and you can see the deploy starts with a build, and then we have some metrics, and we publish both to GitHub packages and to NPM, and then we deploy the static website of this package, or the documentation of this package. And every code that goes through this process is guaranteed to uphold our standards of quality. So it saves time, it saves a lot of pain, and we should use it. So who doesn't want high quality code, right? And if it works automatically, it doesn't require much from us. How is it done on GitHub Actions? It all starts with a folder in your project called .github/workflows. And then we have a YAML file. Anyone didn't work with a YAML file? Or who works with a YAML file? Terraform. We had a talk about Terraform, a great talk. So yeah, YAML files are pretty common nowadays. And we'll see an example for one. It's kind of like JSON, but less clearer for those of us who like JSONs. But it starts with the name. We name the workflow or the action. And we have this on, which is the trigger. Okay, GitHub Actions look at this trigger and says, if there is that trigger, I'll just listen to, in this case, any push to a pull request against the branch main. And I'll just trigger this flow. The flow starts with the jobs. Okay, every job is a new machine, a new instance that GitHub gives you to run some command line, for instance. Okay, this one runs on Ubuntu, but you can also do it on Windows or Mac if you need it. For instance, if you're running iPhone code or something, you want to test native iPhone development. Let's take a look at the real code, actually. So this is the real code, and this is how a job looks like. Okay, it has steps. Can you see it? Just try to, wait. Okay, so it has steps, and they run sequentially. Okay, that means they just run one after the other. And you can see it starts with the checkout of our code. okay, the code of this branch. We set up Node.js because we need it, and then we install dependencies, we test, and our CI passes. Okay, that's a very simple CI. What you can see here is the uses part. Okay, this is, I think, the most important part in GitHub Actions. And this uses part is actually taking existing marketplace actions that people wrote and publish. Many of them were published by GitHub themselves. And you can use them to make a shortcut, okay? We don't need to do the checkout ourselves. We have a marketplace action that does that. We don't have to integrate with Slack. There is a marketplace action that does that. You can communicate with AWS with the correct marketplace, GCP, whatever you need. It's here. So don't reinvent the wheel. Use the marketplace. Anyone knows Running Wild, by the way? We're in Hamburg. You have to know Running Wild. Okay. Okay. It's a heavy metal or pirate metal, however you call them. That is originated from Hamburg. If you like metal, I really suggest listening to them. But let's see how it looks like, how the CI/CD works. So I have this demo, and I hope I have this. Yeah, OK. So I have one commit to push, so I'll just push it. And we'll see. OK. Sorry. OK. So I pushed it, and I have a pull request for this branch. OK, and if I look at the pull request now, I'll go all the way down, and I see that the processes are running. OK, I have this build, and I have the deploy demo, and it works great. But can you see a problem with that? Anyone can note a problem with this picture? No. I'll give you a hint. I can merge without waiting for the process to finish. OK? And that's a very important part when you talk about a gateway. You don't want it to be open all the time, so we have to close it. So how do you close the gateway with GitHub Actions? So you have many configurations to do, but it all starts with the settings of our repository. You'll need permissions, of course. And then we go to the branches. And then we add a branch rule. And we'll protect the main branch. Okay, you can do it for any branch. Let's say you want to debug your GitHub action. So you can just protect a different branch and test the rules on this branch. But you'd usually protect the main or master branch, however you call your main branch. So we talked about pull requests. So I'd like to require a pull request before merging. I don't want people to merge into main without a pull request. Okay, but your team can decide differently. Require approvals. That's another gateway. It doesn't really, okay, it relates to GitHub Actions because it's part of your gateway. You don't want people to merge before there is a review. Okay, it's not an automated step, but if your team decides that code review is part of the process, then it might be important. And this is the part that relates to GitHub Actions. Requires status checks to pass before merging. So if I check this, and I can actually ask the branch to be up to date. That's also important because I want to test the integrated code, my branch, and what's currently in production or in main. So just check this. And I want the test GitHub action to be mandatory. OK? And if I checked all these, and I ask GitHub Actions to prevent merge if tests did not pass or complete, then I have my gateway. Okay, and it will actually give you all the, let's see if I have another one, I don't remember. Oh, build. Okay, so I could also prevent integration if the build fails, for instance. Okay, but let's leave it with test. And we'll create this, and we'll probably, OK. So new new security issues. I'll just try to get past them and approve. Yay. Okay, however, you set up your two-factor authentication, but now I have this rule. Okay, and I'm going to go back to my, is that my pull request? Okay, sorry, I got out of the pull request, so I'll go back to the pull request. I'll go to CodeTalks demo, and I'll see that I cannot merge. Okay, I can bypass this because I'm admin. Actually, this can also be disabled, but you see that I cannot merge the pull request because, first of all, it requires the review as we requested, and it requires us to be up to date with the main branch. So I can update the branch, and I can approve, but and the test pass. But if I actually go here, oh sorry. Okay. So let's say I update it, and all the tests start after every push. Okay, even merging into main into my branch will start the whole process, and I can go into the details and see what happens inside the machine. Okay, so for instance, I can see all the steps. Okay, you see the checkout, the setup node, everything we saw before. It's very easy to track, and if there is an error, you'll see it. And of course, you'll see the process won't pass. It won't be a green V, it will be a red X. So this is how GitHub Actions look, and this is how you trigger them. Okay, this one was the push to a pull request trigger, but there are tons of triggers. You should just look at the documentation. You might see a few there. Okay, so we have our GitHub action running, but GitHub Actions also cost time and money. Sometimes time is money here, because if you're a big company, you pay Microsoft or GitHub by the amount of time your processes are running. Also, if you have big processes, your developers will have to wait, and we don't really like to wait. We want it to move faster. So one way to speed up things, okay, let's say you have lint, you have test, you have visual regression, whatever processes you're running. So you can actually parallelize them. Let's see how it works. Okay. No, that's not it. Sorry. Okay, so I'll go back to the CI, and here I have this build process. Okay, it's a job that only builds. And then I have another job, deploy demo. And then I have another job for lint, test, and end-to-end. And they will run, each job runs in parallel to the other. Okay, because it just raises a new machine and runs the processes. And you don't pay per machine, you pay per machine time. So eventually it will run, hopefully, faster in total, but if you sum them all up, it will be kind of the same as before. So that would save developers the frustration of waiting for long CI processes. But what happens if you want to parallelize certain things, but to start them only when a certain process finished? Let's say you want to run the lint because it's really fast, and only if it passes, you want to run the tests. So this is what we do here. This is the needs property of our job, sorry. And I just tell it to depend on other jobs. And when they finish, I'll start the tests that might be more resource consuming. Okay, so that's parallelization and the ability to play with dependencies in our parallel processes. Another way to parallelize things, maybe sometimes more efficiently, if you have like a matrix of variables. So you could run the tests in various operating systems, like here. I can run it on Ubuntu, macOS, and Windows, and on various Node versions. So in this case, it runs on the 3 OSs here. Okay, so I have already 3 jobs running on different operating systems. And if I'm using the Node version from the metrics, it will actually have a lot more processes running at the same time because it will have all the permutations together. Okay, so you can create very complex matrices to run almost any scenario or any permutation of scenarios that you want. Okay, it's not limited to OS and Node version. This is just strings in an array, so you can actually do a lot of things. We used browser name, vendors. Okay, so we had the metrics for NPM and GitHub Actions. Sorry. So this metrics is pretty cool, also to save you to make your code reusable and create parallel jobs. Another optimization that will also save you actually it's a story of ours. Our team consumed 90% of the time Vonage, my company, purchased from GitHub. And we got a call from DevOps like every day or sometimes twice a day. So we had to tackle it. Okay, and we found out that our NPM install takes a lot of time. So there is a very powerful feature in GitHub Actions that is the caching. And it comes in 3 or 2 ways, and one of them can be more complex, so I add another explanation for it. But the first is the built-in way. Okay, let's take a look at it. The built-in way is, for instance, if I set up Node.js, I can tell it to cache the yarn or the NPM. Okay, it can work the same way if any of you work with Python, for instance, Java. Okay, you have package managers for almost every language. So I think if you do like setup Python or setup Java or Elixir or whatever, you'll have cache for your favorite package manager. And what happens is it saves the global cache of the package manager. So the next time you do install, it runs faster. Okay, but it still runs the install. So it might take a while as it verifies versions against the master version of the package or whatever your package manager does. So you can even do a tighter cache. Okay, you can cache the actual result of our, let's see. So you can actually use the cache action from the marketplace to cache whatever folder in your repository. So in this case, let's say I'm doing this. I tell it cache the node modules. Okay, again, you can do it for any other module you use. And I give it a key. Okay, this is the hash for the cache. Came out good. And then I try to install. And what I do is the cache action gives us a cache hit property. If it's not true, I install. But if it's true, I don't have to install. Okay, it can save me time. So I can actually skip the installation altogether if I already have the files with the correct hash. There is a problem with that because sometimes packages have binaries or some other operating system dependent files. So in this case, I just add this. Okay, I installed Cypress. Cypress has binaries for the browsers, for instance, and I just install the Cypress binaries cache too. So I can work with binaries. Works the same for Playwright or whatever you're using. And the effect is pretty good because I just run the cache, which runs 7 seconds, and the install dependency doesn't run. So it doesn't cost anything. And sometimes npm install, if you ever used it, can take more than a minute, 2, sometimes 3 minutes. So this is a really good way to save, and this actually saved our phone from the rings from the DevOps. Okay, the final optimization is to stop obsolete runs. What happens with our current configuration is that if we push again to monster, it will start the flow again, but it won't stop the former. So we can do, like, let's say we do 7 pushes, we'll have 6 obsolete flows that are running, and we don't want that. It's a waste of time, waste of money, and we'd like to stop that. So we use the concurrency property of the workflow, and we just group our, let's say, tests, or however we want to call it, with the branch name. Okay, that means that every workflow that was triggered with the branch name, with this branch name, or this whole name with the branch, will be canceled if a new one starts, or before a new one starts. That means that at a given time, only one workflow will work for the latest version of our branch. And this also saves time. I wish I knew that before like 6 months before I found it. It would save us a lot. So that was CI/CD. Okay, we talked about CI/CD, but caching can help you with a lot of other things. But automation doesn't stop here. It might actually get to this. Okay, that would be great automation. But seriously, automation can get to any part of your life, but also, let's say, professional life at least. For instance, we can, this is a little tip that can help you organize your automation. You can create reusable actions. Okay, a reusable action is an action that has the workflow call trigger. You can get inputs, and you can use it like this. So this is the unit test. It has a workflow. That's what we saw before. And then if we go to unit tests, that's how my test looks like. I just call it from the file in my repository. Okay, and it works. Just works out of the box. The thing is that you need to remember that it runs from a certain branch. You have to state the branch to run from. So you might want to create a branch for reusable workflows, or always make sure you're using the main, but decide on how you tackle this. But let's say you change if it's main, if you choose the branch main, then and you push to a pull request, you won't see the change. Okay, you'll see what's the workflow that is on main. Okay, so just keep this in mind. So another thing to remember about reusable actions, okay, you can think about them as functions that you can reuse everywhere, but you can't build composite reusable actions. Okay, you can't call a reusable action from a reusable action. Okay, and remember the branching thing. Okay, I put it again because we ate a lot of not tasty things with it. Okay, and that's how you use it. Okay, in this case, we use the main, but remember to decide where you want to take it from. Another way to reuse your code is by creating custom actions. I told you about the marketplace actions, but you can create your own. Okay, it's pretty easy. You use it the same way you use the custom actions, only the path is from your repository, for instance, or any other place you want to put it. And it looks like this. We have a YAML file for the metadata. Okay, I'm not going to dive into the code, but I'll send you the slides later, and you'll be able to take a look at everything. And the index. In this case, it's an hello world, but what you should notice, it uses the GitHub Actions Core or GitHub Actions SDK, which gives you a lot of power to get data and to push messages to the user, to fail tests and retry tests and whatever you want to do with your flow. Okay, and I call it like this. Any of you uses Docker? Docker users, anyone? Yeah. So Docker is great. Okay, it gives us encapsulation and it gives us reliability, and I think that's one of the main uses for me with Docker. And GitHub Actions allows us to run our processes in our own Docker image, which is also very powerful because you can run anything. Okay, how is it done? You can use your own Docker image like this. Instead of when you do the runs on Ubuntu, you can add what container to run it on, because eventually GitHub Actions runs its own image, but you can tell it, OK, run my image. Anyone recognizes Drizzt? Fantasy readers? Anyone? Yep. OK. So this is how you can use your own image, but you can also use services. Services means that you can run Redis, like in this example. You can run your own database. You can run microservices from other images and communicate with them. Let's say you want to create an integration test between services and a database. So that would be another great tool. And we also like to connect to external cloud services. And for this, we need to use secrets. Okay, we have our API keys or whatever. And this is done, again, from, let's see. So in this case, we have the secrets object in our GitHub Actions. And you can populate it like this. I'll go to Settings and go to Secrets, Actions. And here I can see my secrets. Okay, this is the one we saw in the file before. And you can add more secrets. Okay, and then you can use secrets without exposing them. You don't need to put them, to hard code them in the exposed YAML file, which is, of course, not so good. Let's see how it was used. So you see this is the secrets VVD path that we saw in the secrets panel. Final note, I'll stress the point again that you can automate everything with GitHub Actions. Okay, I focused mostly on CI/CD because this is the main usage of GitHub Actions, but you can integrate it with everything through the custom actions from the marketplace. You can use Slack, you can use Google Calendar, you can, I don't know if it can make you coffee, but I think it can do a lot of other things. So just search the marketplace for anything you want to do, and don't reinvent the wheel. For instance, we're labeling, even labeling new issues, okay, or notifying the current person in charge of errors through GitHub Actions. Okay, so you can create CI/CD. I hope you now have the basics to do it. But you can also automate everything. Okay, so if you're using GitHub Actions just for CI/CD, you can enhance the experience of all the developers in the team. The optimization is, I think, is a super important part. And as I've shown you, you can also improve management of the team by auto-labeling stuff, auto-assigning stuff, and even auto-annoying your friends by automatically sending Slack messages in bulks. Thank you.